multi-million audience, mostly like social networks. So all of them use Postgres. It helps to scale and to develop quickly. I'm also founder of Russian-speaking Postgres user group, which is on meetup.com #2 currently, right after New York meetup group, but above as San Francisco Bay Area. We recently passed it. So, and also, if you are interested in Postgres-related stuff, good articles, news, please follow me on Twitter, PostgresMan. And I recently moved to the Bay Area, and I'm currently doing consulting for Postgres-related stuff, especially in terms of performance and scalability. This slide I wanted, actually, these slides were presented at PostgresConf last week in New York, and I had full room, full house, and it was very well met, this topic. But it looks like this conference doesn't respect Postgres. Yeah, I hope it will change with yesterday news that Percona now supports is going to support Postgres, providing support services. This is analysis. This is analysis of Hacker News job postings. So, how many times particular technology is mentioned among vacancies? So Postgres is growing, and if we go to the recent thread, April 2018, and try to find Postgres, we will see that among about 1,000 messages, Postgres has more than 100 mentionings. But if we try to find DBA, you will find only one mentioning. It looks like startups don't need DBA anymore. It's increasing. Okay. So this is like, I'm observing this already like second year, and DBA is not very popular term among job postings on Hacker News. Why is it so? Possible reasons are clouds. Many tasks are already automated, and DevOps, and probably you know some other reasons. It looks like it's similar to sysadmin term, right? Because it was substituted by DevOps term. But for this case, DBA, we don't have new term. Probably it will be invented soon. So which tasks are already well automated if you're on clouds or are using some DevOps modern technologies? First of all, you can provision database instance. You can set up automated backups and reliable backups, probably incremental backups. You also can provision replicas and switch them if it's needed. Sometimes also automated failover is provided by cloud technology. Which tasks are not yet automated? If you need to tune your database to find bottlenecks, you need deep database expertise. If you want to have detailed monitoring, it again needs detailed expertise in databases from you. So any tasks which are related to optimization, this is like the point when startup goes to guys like me and says, okay, please help us to scale and to optimize. And this usually means that some database parameters need to be changed, or some indexes need to be changed, or just added. So this is usually some specific steps need to be provided to fix some problems, right? And this story is how it looks like. Currently, if you have even detailed monitoring, you react to problems, right? So monitoring shows you problems on production where already you have a lot of data and some query becomes very slow, and your users, your customers already experience problems. So with monitoring, you can only detect performance bottleneck, and usually you need deep expertise to understand it and to fix it. Better idea would be to fully automate this detection, and even more better idea, like second level, is how to predict these bottlenecks. Because if you're experienced DBA, you don't need to wait until 1 million or 1 billion rows will be inserted to the table. You see, oh, this query uses this column as a filter, as a predicate, and there is no index there. So even if table is empty, you can tell developer that index should be created. So this is like prediction. And fully, like third level is prevent bottlenecks. That means that we can predict them and fix them before they hurt our production. I observed during some period I observed my actions when I optimized databases and actions of my colleagues, and found that a lot of activity can be automated. And I started from very, very, very simple thing. All of us are using for many years useful queries that extract statistics details from internal statistics from Postgres and present them these details in some human-readable report. And for example, if you're, let's say that a friend of you asked you to help with database performance, and he or she provided you credentials to connect to this instance. First thing you would probably want to learn how big is this database, or if this instance has several databases, how big all of them. And next question would be, second question would be probably, how big are database objects like tables and indexes inside it? What would you do? In Postgres, you would connect with, by the way, who of you prefers probably more console and terminal tools, other graphical tools? Only 3. So other people prefer mostly graphical tools, right? So, okay. I usually prefer console tools because it gives me better understanding, and like you connect closer to your data, and it's usually faster, and I connect from anywhere, even from my smartphone, if it's needed, or like iPad, doesn't matter. And in Postgres has very good console. It's called PSQL. It has internal help. You can call it with \question mark. It will show you all available commands. It has autocomplete, multi-line support, and so on and so on. And if you forgot SQL details of huge, like SQL, all possible variations of select, for example, statements, you can write just \h, and you will see like grammar of SQL command statement. So back to our example. We connected to server, and we want to see database sizes of databases inside this instance. You can write \l+, and you will see databases. You can write \d t, for example. It will give you tables in the current database with sizes, or \di with indexes. This is, I use it a lot. And let's try to do it in PSQL. You will see this. And this is horrible report. I cannot understand which database has which size, because like everything is messed. This is because by default PSQL uses less to provide paginated output, and this can be very easily fixed using special addition to PSQL. It's called PSPG, and this is highly recommended addition to PSQL. It allows you to see the output in nice looking view. You can horizontally scale this table, and you can navigate with just with your arrows on your keyboard. So, okay, back to the question: which table is the largest one? Probably the first one, _dev. This is my laptop. It has 36 gigabytes, right? Next question: which is the second largest database? It's not obvious, right? You need to quickly analyze 16 numbers, and some of them are megabytes, some of them kilobytes. So this is difficult for me, at least. This is second, right? Probably this one is probably second, almost 2 gigabytes. If we go to test database on my laptop, we have 37 tables there, and this is impossible task for me. I cannot find largest table or second largest and so on. So, okay, what I'm talking about here, I'm talking about order. And usually, all of us who work with PSQL do this. And if I ask Postgres experts how many times did you do this, I do this 12 years, right? So I want some snippet. I want some multi-line SQL statement which will give me a good report. So that's why I wanted to create something more handy. So that's why I created this project. This is open source project. You can use it. I called it Postgres DBA, and this is a useful set of very handy reports which I use on daily basis. It gives you menu right inside PSQL. So you write just colon DBA and see this menu. And this menu is extendable. You can add your own reports to it. So in our case, when we want to see sizes of databases, we just type colon DBA and ask for report number 1, database size with statistics, or report number 2 for table sizes. So let's type 2, and we'll see this. This is a report of all tables existing in the current database we're connected to, and this is very convenient presentation of list of tables. So we see that check _ C is the biggest table, and it occupies more than 1/3 of all database, 34%. And data inside this table is 400 megabytes, and indexes only 200 megabytes. And it's not toasted. This is an internal mechanism in Postgres where when you need to insert very long record, and it's toasted to slices, and each slice is stored separately. So this is very good. And I also added total. You can see how many megabytes or gigabytes all tables, all data, or indexes in this database occupy. Also, if you have table spaces, you will see here table spaces related data. Important notice, this tool needs most recent PSQL version 10 because it uses \if command. And this is installation, just 2 lines. You clone repository and put 1 line to PSQL RC file. That's it. But this tool can work with older versions of Postgres like 9.6, 9.5, and older. And if you want to connect to remote server and you have SSH access to it, you can use SSH tunnel. It's described in the README. So colon DBA, and that's it. Other reports. This report shows you information about current instance. You can see what is uptime, how all these statistics, how many checkpoints occurred, how many of them are forced, and so on and so on. Cache effectiveness, percentage of successful commits, number of conflicts, deadlocks, and so on. This is useful to understand possible problems with performance. What's next? this is Postgres specific topic, table bloat. I will skip some information to save time because I have many slides to present. So I also included several ways to estimate table bloat and index bloat in Postgres. Table bloat is when you update or delete your records. Physically, they are still present, and special process autovacuum needs to mark them to available, this space to available for new inserts, right? So you need to control bloat level, especially because default settings of Postgres are not very, in terms of autovacuum, make it not very aggressive, and autovacuum starts only after 20% of records are changed. So if you have OLTP type of workload, you need to reduce this percentage probably to 5 or 1%. So bloat estimation in Postgres is relevantly difficult topic because to get real numbers, you need to do full scan of data, and this is expensive on master or on replica if it's under workload. There are several reports which are doing this estimation based on some tricks, and these 3 links are actually almost the same. But the problem with these reports, I will show you. If these reports only are estimations, and sometimes they are very wrong. For example, if you create these 2 tables, first table is, I have this one thing. So first table has char 1 byte, then number 2 8 bytes, occupies 8 bytes, and then char once again 1 byte. Second table is different, and we inserted million records. Second table is char integer 8, so 1 byte, 8 bytes, right? So once again, 1 byte, 8, 1, and 1, 1, 8. The interesting thing with these 2 examples that they will occupy different disk space in Postgres. Because, did anybody hear about this problem or no? Okay. This is because you can see that all disk space is different. First table is bigger, 8 bytes bigger, at 8 megabytes bigger, almost more than 15%. So this is because when you insert 1 byte and then second column is 8 byte, you lose 7 bytes. It's just zeros. It's called alignment padding, and it's shown here with very useful tool which allows you to look into your data, raw data, and indexes, tables. It's called PG hex edit. Just with hex editor you can see it. So here we see A character. It's here, 61, and then 7 bytes of zeros. This is padding. Then 2 occupies 8 bytes. These zeros are okay because we needed 8 bytes. And then again, this is character B, and this is padding for whole tuple, 7 zeros. So overall, we lost how many? 14 bytes for padding. In the second case, it's different. We put A and B all together, and then they lost only 6 bytes, and then no padding in the end of a tuple. So the difference is 12 bytes. 14 here, 6 here, 12 bytes. So if we just change column order manually when we define our table, we can save a lot of space. In this case, 15%. And you once again, you can see it here. Second table is 8 megabytes smaller. It can be a huge gain if you have very, very big table. Okay, so when estimation is not enough, you can use report B3 and B4 from my tool. but you need to do it only on some replica which is not under load, because otherwise you will lose your cache and overload. It can hurt workload. Another trick is very simple. You can just analyze single table, just create a copy. In Postgres you can create table as select. This is very, very simple way to clone your table without indexes. So you just clone table and then analyze difference between sizes. You just call my report number 2 and see difference between these two tables, original and cloned. Okay, what's next? Indexes. Reports I1 and I2 are very handy to understand unused or redundant indexes. For example, if you have primary key for 2 columns, column A and column B, and you also created column index for column A, it's not required, it's not needed. And this report, I2, will print statements, drop index statements, and also create index statements, and you can just insert it if you have active record or you use some other migration tool to change your database, to put DDL. You just copy-paste these 2 blocks, and that's it. How many uses migration tools? When you just add column, you write it to some tool, and in case of problems, it will roll back, like Sketch or Liquibase. This is must-have, because you cannot change database structure manually. It's not the right thing to do. Right. So everything should go to your Git repository, or what do you use, and so this is must-have. And this is just already ready to insertion. Only one notice in Postgres: you probably, if you're under workload, you probably want to not just create index, but create index concurrently, which will be slower, but will not lock your table. Okay, slowest queries. This is interesting report. It groups. This is it's based on pgstat statements, default tool in Postgres, default extension to analyze queries. It groups queries, removing parameters from it. So and summarize statistics. How many time it was spent on this query? What was minimum time, maximum time, standard deviation, and so on. And this is just a way to look at it, quickly find the slowest query, not just particular query. Because, for example, you can have 1 millisecond query, but which executed a million times. And it will give you a huge amount of time and will probably be number 1 in terms of workload on your instance. And optimization from 1 millisecond to 500 microseconds can give you a huge win on your and reduce CPU and I/O load. So this is example of why we need to have more automated tools to work with database. This is a real example from one of my clients. We noticed that all queries to one particular table had predicate like this, it isn't shown here. Consider that you have table, you have a lot of queries, and all of these queries have some filter like A more than 0, right? So in Postgres, you can create index not on the whole table, but on some part of it, right? You just specify create index, blah, blah, where A more than 0. And this will reduce the size of index. This means that index scan will be faster, right? So we decided to do this. We added to all indexes except primary key and unique keys. We added this condition, A more than 0. And select became faster. Cool. But with monitoring, later we noticed that updates became 15% slower. And this is very Postgres-specific topic, because if some particular column participates in index definition. This means that updates cannot be hot updates. Hot updates when Postgres skips, doesn't touch indexes at all. So before our change, we had hot updates for almost all updates we did. But after change, when we incremented this A, for example, but after this change, A became part of index, not physical part, but logical part, right? And if we increment A, update table set A equals A plus 1, this means we cannot do hot update. Postgres cannot do hot update and needs to touch every index and create index entry in each index. So indexes became 50% slower in our case, and this is trade-off. You can speed up select, but update can be slower. So, and this is so difficult to analyze everything manually, right? So if I change this, what the whole picture will be? We can speed up some query, but slow down some other queries, right?
Just a quick question. Is that specific to having the word class on the index definition? Or it can also be just if you declare an index just for this column without a word class, that is slowness on updates. It can be in both cases?
First of all, if you have a lot of indexes, all of them will slow down your updates. But if you're updating a column which not participates in any index definition, it will be faster in general. In Postgres, this is Postgres specific thing. And if your autovacuum is very aggressively tuned. So, pardon me, I missed your question.
Yeah. Just if having the word class definition in the index, as you mentioned, where A is bigger than 10,
right.
For example, in your index, is that makes it worse, the slowness on the update, or is
it depends on your updates. For example, if you need to quickly find columns by the same predicate, your updates also use the same indexes, right, to find rows to update. But in our case, so this probably will give you some gain in performance. But in our case, we updated using our updates found indexes using primary key. That's it, just single row, primary key, very fast index scan. But some mechanism of update process itself were slower because it needed to touch every index because this column were participated in index definitions. So my general idea is that you cannot manually predict all changes, and you need to do experiments, right? So if you make some change, in the best scenario, you would take your real workload and check this workload on some example database cloned from production, for example, and see how it was changed after, how performance were changed after your improvement. This is probably not improvement, but making things worse, right? So I wrote this article about this particular story. Details are there. And this is about how you can extend this Postgres DBA toolset. It's very, very easy. Here we just put, we write some SQL and regenerate menu, and that's it. And our report, it's called time. So it's time, and it took it from file name. Very simple logic. Okay, also, if you want to see raw data, you can, from menu, you can call X. It's here, X, and you'll get wider reports. This is ready for consuming by machines, like for API. Okay, so I have a lot of plans for Postgres DBA, and if you use Postgres, please join this project and use it. And if you have some ideas, I would love to see it, to hear it. back to automatization. So the main idea is to prevent problems before they hit our production. How can we do it? First of all, Postgres has this tool, PG statements. This is extension. It's widely used in Postgres community, but it has its own problems. One problem I don't like specifically is that when we just threw out our parameters from statement, this doesn't guarantee that we group similar queries. For example, if we have query select star from table A, where column C1 equals 1, this can be sequential scan. And when we have query equals 2, it can be index scan, right? It can be very different things, but this tool groups them, thinking that this is same queries. Also no historical data, but if you have monitoring system, it can be very easily resolved. No logs, wait event data, and so on and so on. No sample queries, so you need to process logs and match queries from logs with this data. This is just a view in the database, and you can select it. So a lot of problems, and usually DBAs, Postgres DBAs, with this tool find the slowest query group, and then they go to log files and find manually or using some grep, I don't know, examples of these reports, because this allows you to explain, analyze, and then improve them. This is ridiculous, and sometimes you cannot access Postgres logs. For example, on Google Cloud, you cannot access Postgres logs, only error logs. So you are sitting and thinking, oh, okay, which parameter can I use in this group? Because we see only question marks instead of parameters. And to analyze and to improve performance, we need these parameters. So another extension, it's not very popular, but it's available on RDS, and it's very good. It's a very good thing. It's called auto-explain. If query in runtime spend more than some threshold you specify, it will be logged into Postgres logs, not just query, but with plan, explain. And you will see how it was executed. And this is very useful, because if you even have some slow query, next day you try to analyze, it can give you different plan, because statistics changed. So we started to play with this and to try to match these things. And there are some obstacles. There is also good tool from France. It's called PG Badger. It's open source. It analyzes logs and also groups queries and creates a lot of reports, 78 reports. So you need to be expert to find proper report and understand what are the things in your database. There are some commercial systems, monitoring systems, and PG Hero is free. Others are paid systems, and all of them, as I've said, have one big problem. They allow you to react to problem on production, not to prevent. So, yeah, they require a lot of manual actions. You need to be a database expert to see to find exact bottleneck and match it to some CPU utilization or I/O, and then react. This is reactive approach. But we need proactive approach, right? And this I already mentioned. This example I already mentioned. If that developer created this table and started to query using param equals something, you say, hey, you need index on param1. This is DBA can predict. How can we do it automatically? And moreover, how we can suggest user, oh, you need to create this index. There are some tools, for example, PG Hero does this. Also, Vivid Cortex does this. They can suggest index. But the problem is that if you have a lot of queries, You have thousands of tables, a lot of different queries. You have a lot of suggestions. And you cannot understand where to start. And the idea is to use machine learning to predict which one will give you the most performance gain, the best performance gain. You will start from it, then next, then next. But before we can create this machine learning AI-backed tool, platform, we need to solve experiments problem. Because when you are DBA, you have some one or several clones of production or some shuffle data on staging big enough to experiment with. And you usually combine several experiments because creating replicas is a long process, it's expensive. So you check this idea and just combine in one day of DBA activity. So experienced human DBA makes a lot of experiments. This is like, I'm currently, this thing is on R&D stage. We have some prototype, and we're experimenting a lot with this prototype. And our first goal is create very, very convenient and tool which will allows you to launch a lot of experiments without manual activity. You can build this yourself using tools mentioned here. I will not spend time here. You can see it later if you use Postgres with a lot of useful tools to automate, to help you build automated pipeline for database optimization. And even you can do machine learning inside Postgres. This is a crazy idea, but it works from Pivotal. You can replay logs from production and check and analyze a lot of data. So the idea with experiments, this tool is currently under alpha testing. We just using EC2 spot instances, which give our low price, like 70% lower than usual EC2. And spot instances are very good. They can survive several months from our experience, because Amazon optimized this process. So you can get EC2 instances for 70% lower price, and this is good for experiments because they will not be killed next hour or even next day. So we automatically launch EC2 spot instance and create a database there or some part of your database. And using PG replay tool, we replay production logs from your database for production. We turn on all parameters. Usually you won't turn this particular timing parameter because it slows down everything. But this is experiment, and we can slow down everything. And then we collect a lot of statistics and to metadata storage. And each experiment actually consists of two these activity, right? You launch one instance and do everything without change, and the second one is with change. For example, you add some index and want to compare, or you change some PostgreSQL.conf parameter and want to compare. So instances are the same. They can launch simultaneously, and metadata is different from production, but it should be comparable. There are big challenges like how to load DB snapshot quickly, but this is we have no time to go to details on these topics. This is example of report. Before we had overall time spent of all our queries 45 minutes. After 43, good, we saved 2 minutes, and receiver for select we saved 3 minutes. But for update, this is the same example I mentioned before. This is related to hot updates. So our updates were slowed down 15%. So we need to analyze what happened. And if you press this, you see details and graphs with utilization of CPU, and so on. And you can also see samples of queries. So this is a very good tool. And if you have some changes on database, and imagine that this tool checks every change before the change is deployed to production. This is amazing. You can control performance and avoid bad changes, right? This looks like continuous database administration. So we create 3 robots, are creating 3 robots. One is learning how to tune PostgreSQL.conf and how to control resources utilization. Next one suggests how to optimize queries, especially which indexes should be added. And third one, Nancy, she's a very important part of this team of DBAs, artificial DBAs. She is who creates experiments. So if this Joe suggested to create some index, you can doubt, is it good or no? Because he says, add this index and you will have 30% of performance gain. You can press experiment button and ask Nancy to make experiment, and she will report to you details. This is our platform. You can sign up for early access to this platform. This is, I think, it. So automate everything, make more experiments, and try to prevent performance problems before they go to production. Okay, that's it. Questions? Yeah, you can follow me on my Twitter, and I will post it today. The question is, does alignment padding thing? Right. Does the column order affects performance? Of course, it affects performance because some part of performance. First of all, reading words of 8 bytes it's like the same, but in the first case you have 3 words of 8 bytes. In the second case, only 2. And if you achieve 2 kilobytes, Postgres will apply toasting, will slice your data and store in separate relation internally your data separately. So you don't want to achieve these threshold of 2 kilobytes soon, right? So of course, compressing data is a good thing, right? It affects performance. And sometimes I saw 40% of wasted time because of alignment padding, and table was very heavily toasted. This means insertion slows down, selection slows down, everything slows down. Yeah. Yeah. Question. Right. Question is, which migration tool is better? Which one? I'm just repeating the question. I personally prefer Skitch. Skitch, SQITCH.org. It works with all databases, MySQL, Postgres, Oracle, all of them. But Liquibase, I observe that in enterprise sector, Liquibase is very popular. There are a lot of alternatives. I prefer Skitch because it doesn't require, it works well with any language, Ruby, Python, Java, any. And it has also deploy, revert, and also verify part. So for each change, you can write test, and then include it to your continuous integration server to automatically change on each change, on each commit to Git, each push to Git. So this is a very good thing. I usually write a lot of tests, so this is like some coverage or test coverage of your database. Any more questions? Yeah.
When running alters, I have noticed, I have been using Postgres for like 6 months or something, and I have noticed that alters, when you add new columns and use
default values, good question.
Huge difference.
Yeah, good question. If you alter and add column and specifies defaults, this means that whole table needs to be updated, and this is very slow. Usually you add alter without default and then add default.
Is that just the way around it?
This is a way to, yes, work around for it. Good news that in Postgres 11, patch was already committed and accepted to, I don't remember exact syntax, but it will be possible with one line, alter table, specify column, and skip this update. If you're okay with nulls in this column, you can specify default and nulls will be present and no need to write 2 lines of code. But it's not difficult to write 2 lines of code. The problem is that many times you just forget about it, right? And I did it a lot of also, like I just forget, and we don't have continuous DBA, and our development and staging are small. Then we deploy to production and see that this alter works for minutes, for hours, oops, right. With this tool, you will see that something bad is going to be changed in database, and it allows you to compare performance also. Okay, thank you so much. Yeah. Thank you.